Hello everyone, my name is Wenyu Zhang. I'm from National Taiwan University. The topic of my presentation is injecting salesperson's dialogue strategies in large language models with chain of thought reasoning. Before we dive into our work, I want to briefly talk about the background. Traditionally, in sales customer scenario, such as product recommendation system, we usually utilize pipeline approach. For example, here the user says, I like sci-fi novels. The pipeline process the input from module to module and understand the user like sci-fi, and the agent talk about the themed restaurant. And we can easily know why the model generates such response by looking at the output from each module. However, after the LLMs came out, things have changed. People start using end-to-end model for dialogue system, and such model does not provide any clue about how the model generates the output. And for product recommendation system, it is very important to know why the model recommends a certain product to the users. To resolve the problem, we first have to know what kinds of reasoning should the model use. Thus, we seek the help from human expert, which is salesperson, and come up with the following strategies. First, the user did not implicitly mention any potential intent, the model should continue chatting. Second, if the user implicitly mentioned the intent, the model should smoothly pivot the conversation to a topic. Third, if the user did not change the topic, and the model should continue the topic. Finally, if the user explicitly shows his or her intent, the model should hand over the conversation to TOD agents. And what we're going to do is to incorporate these strategies to large language models. And the first thing we do is to put the instructions into Llama. We have tried to use zero-shot approach to test if the model has the ability to follow the instructions. And here's the example of the Llama 2's output, and it's obviously that it didn't work. Thus, we decided to incorporate the strategies into a dataset and tune the model with it. Our motivation comes from the previous work called Salesbot. They also synthesized the dialogue transitioning from chit-chat to text-oriented scenarios. They create such datasets called Salesbot. However, these work have some limitations. The conversation itself is aggressive in terms of transition, and it is also unnatural because of the model they used. This dialogue demonstrates the two limitations I've mentioned previously. In the context, the user and the agent are talking about their accident experience, and all of a sudden, the user says motorcycles are a lot of fun. Right after the agent talked about his motorcycle accident. And this is really inappropriate in a conversation. So we think this kind of dialogue is unnatural. And all we're going to do is to revise these dialogues for better naturalness for LLM common sense. In addition, there is only one transition turn from chit-chat to text-oriented dialogue. Imagine the salesperson always recommends you a car right after you speak something about traveling. This is too aggressive and not comfortable. So what we're going to do is to increase the number of turns for smooth transition with LLM rewriting. So what have we done? We created data, revised from Salesbot. We create a more natural and smoother, and we label the intent and policy from the previous dataset. Also, we train a new model called Sales Agent. It takes input from the user and output the agent response and the thought, which is the user understanding and policy selection. Here is the entire framework we use for Salesbot 2.0, and our base model is GPT 3.5. In the first step, we ask the model to detect inconsistent utterance with reason and make the chit-chat dialogue longer and more natural. After revising the chit-chat dialogue, we ask the model to detect the potential intent from the user based on the context. Then, with the detected intent and context, we ask GPT to continue the dialogue and pivot the dialogue topics related to detected intents. Also, to avoid aggressiveness, the transition should be smooth without abrupt topic change. Finally, we ask the model to detect the trigger point where the user explicitly shows the intent or asks for recommendation. And this is the point where to hand over to text-oriented dialogue. Let's go back to these 4 strategies. We can find out that these 4 strategies can be easily mapped to the different stage of the framework. So the first one, the user did not implicitly mention anything. It can map to the first module, chit-chat revision, and the second can be mapped to intent detection, and so on and so on. Therefore, with this approach, we can not only create a smoother and natural datasets, but also label it with detected intent and the corresponding policy. Now, with the data, we can train our model with it. If you do naive tuning, then our model is nothing but a black box, just like the other large language models. However, with the intent and policy label, we can now break the black box to see what's really going on before the model generates the response. To enable the model with reasoning skills, we utilize the chain of thought mechanism when tuning. Here is a sample from Salesbot 2.0 without chain of thought. And here is the one with chain of thought. You can see that at different stage, the agent generates different understanding and policy correspondingly. In our experiment, we use Salesbot 1.0, which is the previous work, as baseline to compare with our datasets. The model we used is Llama 2 7 billion chat version. Below is the general statistic of the 2 datasets, and the right-hand side is the intent included. To see the quality of the revised data, we evaluate them at dialogue level. We use the same model as agent as user simulator, which is Llama 2 7 billion chat, and we use 250 different personas as the user from chat generated by ChatGPT, and the maximum turn is 15. And we use GPT-4 as evaluator for the following perspectives: naturalness, coherence, consistency, aggressiveness, and smoothness. And here is the result. You can see that our dataset outperformed previous work at every perspective in terms of naturalness, coherence, consistency, aggressiveness, and smoothness. Here's a simple example from qualitative analysis, and the user persona is as following. The user is Daniel and is a marine biologist and fascinated by the ocean. This is the conversation between Daniel and Salesbot 1. In the transition turn, the model says, "What kinds of things do you like to go to?" This unnatural utterance is obviously not what human being would say. And also, right after that, it hands over the dialogue to text-oriented dialogue without further talking, which is really aggressive. And here is the conversation between Daniel and Salesbot 2. Apparently, the conversation is much longer, which indicates the model does not aggressively pass the user to TOD agent. Also, the conversation has been direct from a road trip to users' local attractions and then to the local hotels. After the user shows the interest about the new hotel they're talking about, the agent finally passed the conversation to TOD agent. In conclusion, we improved the dataset with smooth transition, natural dialogues, and we labeled with user intent and agent policy. And also, with the chain of thought reasoning, our model is able to provide its thought along with response to better control and explain the behaviors. And finally, the evaluation results shows that Salesbot 2 achieves better performance. Thank you.